simultaneous equations involving exponential equation. And we are to example that we have is m plus 6n is equals to 3 as our equation 1, and 2 raised to the power m plus n is equals to 1 out of 4 as our equation 2. So let's try to work on the equation 2 for it to become linear so that we handle the simultaneous equation with any of the two methods, either by substitution method or by elimination method. So now looking at the equation 2, where we have 2 raised to the power m plus n is equals to 1 out of 4. Now 1 out of 4 can be written in mathematics. It can be written as 4 raised to the power negative 1. That is the inverse. 4 raised to the power negative 1. Again, 4 can be written as 2 times 2 in mathematics. So 2 times 2 is the same as 4. And indices, 2 times 2 can also be written as 2 raised to the power 2. 2 raised to the power 2. So this one means that 4 can be written as 2 raised to the power 2. So in place of this 4, we are substituting 2 raised to the power 2. So 1 out of 4 can be written as 2 raised to the power 2 multiplying negative 1 here, which is the inverse. And then negative 1 multiplied by 2 will give us 2 raised to the power negative 2. So here 1 out of 4 can be written as 2 raised to the power negative 2. If this point is well established, then the work is happily solved. So back to equation 2 can be written as 2 raised to the power m plus n is equals to 2 raised to the power negative 2. Now something interesting is happening here. When you look at the base, here is 2, here is 2. And once the base are the same, we can equate the exponent, that is their powers. So we are going to establish that fact that since the bases are the same, here base 2, here base 2, now we equate the exponent. So equating the exponent, we are going to have m plus n. This is m plus n, which is equals to here the negative 2, which is the power negative 2. So now here becomes our equation 3. Equation 3. So we are looking at equation 3 now. From equation 1, I have m plus 6n, which is equals to positive 3 as my equation 1. So with this, we can use any of the two methods to solve, but quick, let's use the substitution method, where I am making m the subject of the equation from equation 3. So it's going to be m is equals to, here I have negative 2, positive, so inverse will be negative n as equation 4. As equation 4. So we are trying to do substitution here, meaning that when back to equation 1, wherever we see m is equals to negative 2 minus n. So we say that put equation 4 into equation 1. So here my m here will be negative 2 minus n. Already I have plus 6n, which is 3. So here negative n plus 6 will give me 5n. So negative 2 plus 5n is equals to 3. Let's group like terms. I am getting 5n is equals to 3 plus 2. So my 5n is equals to 5. How do I get my n? I divide both sides by 5, and I'll be getting my n is equals to 1. Now that my n is 1, back to equation 3. From equation 3, I have m plus n is equals to negative 2. So if my n is 1, here it's going to be m plus n, which is 1, is equals to negative 2. Let's group like terms. I'll be having my m is equals to negative 2, here inverse negative 1. So my m is equals to negative 3. So that is that. Now I know that my n is positive 1, my m is negative 3. So this one, so we conclude by saying that m n is such that when my m is equals to negative 3 and then my n is equals to 1. So that is that, and I think we are enjoying the math. Thank you for your time being with me. Let's keep practicing. And then again, if you have any question, you can ask me and I'm ready. In fact, I am ever ready to answer you. Thank you once again. Bye.